Hello, my name is Clay Collins. I'm an InterNACHI certified master inspector. I've been doing this for about 20 years. I've done over 8,000 inspections. Today we've been invited to inspect this home. This is a two-story Brighton home, 4 bedrooms, 2.5 baths. We would like to just invite you to walk with us during this inspection. We're here to inspect the roof. This is a 2-story house. It was built in 2012. There's no evidence that the roof has been replaced before, so we have a roof here that's about 12 years old. 2-story, we're not required to walk on the roof per InterNACHI standards. The Texas standards requires that I walk on the roof unless I'm just not able to. So there's only this small section here that would allow me to inspect it by ladder per the InterNACHI Standards of Practice. I will be going up on that portion of it that I can get to. Gutters are a part of the Standards of Practice for InterNACHI under the roof section. This is the only portion that has any gutters. Now I do recommend to my clients that they have gutters all the way around the house. If it's a horizontal surface, it should have gutters, especially in areas where the runoff from the roof will come directly down onto a lower roof. That will just wear out the roof very quickly. From this level, we're able to look at the eave. The lower course is sealed as it should be. I'm not going to pry it up to be able to look under there. That would expose it to wind damage more than anything else. So that part looks good. The gutter that we're seeing has a lot of the granules that come from the runoff of the roof. That's about 12 years worth of runoff right there. The gutters appear to be clean other than this. The downspouts go out to the side. We'll take a look at that in a little while. The flashing that's visible here looks good. It comes down past the wall, so the runoff is not going to go behind the wall. A little bit of caulk missing here, but that's not an issue. We have the flashing is visible. The siding comes down less than 1 inch or 2 inches from the roof cover. Well, it turns out that this is a mighty steep roof, and we were going to use the drone to do some of the filming. We also found out that we're within 4 miles of 2 airports, and that prevented us from using the drone. In order to protect the cameraman, we let him stand on the ground. I walked up and did my inspection. Now we're going to walk around the perimeter of the house and I'll discuss what we saw. Keep in mind that if you do choose to go in the house, safety is paramount. I used special shoes to do it. If you don't think you can do that, there's nothing to gain from walking on the house and getting hurt by doing that. This particular pair of shoes is Cougar Paws. This is just a rubber piece that keeps the sole from being exposed and getting dirty. It's got an adhesive grip. This is replaceable. This makes it easier to walk some of the steep roofs, but there's some that you still can't do. Be safe above everything else. This portion of the roof I could only look at from the top or down here with binoculars. There is a short, flat hawk type vent there that is possibly for a dryer. We'll continue to look at that. We have the taller vent because it's a 3-inch vent. That is for the water heater gas flue. The flue itself is supposed to extend higher than anything within 10 foot of it. But this is not a code inspection. So as we inspect the water heater, what we want to determine is whether it's performing, whether it's functional, whether it's heating the water. The fact that it might not be high enough would be an issue of drafting. If there's no issue, then I don't have an issue with how high it is. We do have some gutter over here. That means somebody added the gutter system and a downspout, but there's still some areas that I would recommend additional gutters. There are going to be times that there's portions of the roof that you just can't get to. You can't see it from the ground, you can't see it from the roof. This one's partially obscured by trees. There will be times that fence lines and property lines and additional homes and buildings are going to just keep you from seeing it. Do the best you can. I would recommend that you take photographs of the areas so that you can see what you can't see, so that you can document what's not visible to you. That doesn't have to go into any report, but it's great information for you in the future. And you need to be sure that you describe to the client that section that can't be inspected. Here we have the trees that are just blocking it. I might use binoculars to get better positions and angles. And then I'll even take pictures of my binoculars showing that portion that's visible or not. This is an architectural shingle. Sometimes it's referred to as a dimensional shingle. Basically, you have the shingle that has other pieces laid on top of it to give it a three-dimensional look, mimicking a wood shingle roof. Because of the extra thickness, it has a longer life. This one is typically sold as a roof cover that has a 25 to a 30-year lifespan. We don't talk about the lifespan. We don't recommend or make a comment about its remaining life because we have no way of knowing. The tree could fall tomorrow, the hail could fall tonight. But you should recognize that an older roof, an obviously older roof, might affect the homeowner's or the purchaser's ability to buy insurance. So if you have an older roof, that should be mentioned even though you're not commenting on remaining life. When you have a dimensional shingle in a valley, you cannot weave them. The manufacturer does not allow you to weave dimensional shingles, and that's because they can't lay as flat as they should. So what we have here is what's called a closed cut valley. In this particular valley, you see that the higher roof, the larger plane of water runoff, is actually going underneath the cut in that valley, and that's the opposite of what it should be. But the reality is, if the flashing in the valley itself is done correctly, that really won't have an impact. So I wouldn't get too worried about reporting that. What you need to know is you should be looking closely in the areas underneath that in the attic space for water damage. In addition to that, what we see is a satellite antenna. What's important about the antenna is that they've made the roof watertight and they've drilled holes into the roof to mount the antenna. There's actually a flashing device that's designed to hold an antenna on the roof, but in 20 years I've seen it used one time. And it all comes down to money. Nobody wants to spend the additional money on the flashing when they can just drill holes and put some caulk there. So again, if you see penetrations like that, what you're looking for is water intrusion. That's the most important. And I have seen many cases where the leak caused the roof damage and the antenna was just basically leaning on its side because of that. You should encourage your clients that they should always look for water intrusion, especially at places that there are penetrations. On this side, one of the first things we see is the downspout is missing. You can see the piece laying there on the ground. That's a reportable deficiency. As is, the water's just going to run out. It's going to cause erosion, despite the fact there's a splash block, so that needs to be repaired. Also, if you look on the roof, you see the drain waste vent that sticks out. That's just a piece of PVC that's been painted. You see the small section of it that's white. That means there's been some movement. Most likely it's just the retraction of that rubber boot. When I was on the roof, I saw that the boot was cupped a little. There are some of the boots that very specifically say do not paint. There are other boots that are silent. They don't say paint or not to paint. Over time, those rubber boots can deteriorate by UV rays. So when you're looking at the boots, look for cupping. Look for places that they're split and water could run through. And if you see one that says don't paint and it's painted, as long as the boot's not damaged, I don't think I'd worry much about it. Something else to note with these gutters, and this house has more gutters than I originally thought, but from the front there are sections that still need gutters, especially above the roof. But if you'll take a look here, you'll see that these are sectional pieces that have been placed together. This is the type of gutter system that you could buy from the big home improvement stores. This is not the continuous gutter where they bring a truck in and you say you need 50 feet of gutter. They run 53 feet through and you have a gutter-shaped channel. These pieces tend to leak at all the couplings. Plus, homeowners are generally the ones that do these. And where they're pieced together, they fall apart or they're not sealed. So you're going to see a lot of leaks in sections like this, especially at the corners. Even with the manufactured gutters that come in an unseamed length, at corners they have to have seams, and that's where you're going to find leakage, and you need to pay attention to that. You have gutter failure, gutter leakage, both of those should be reportable. This is the back side of the house. There's several things that I like to note. I remember that my client doesn't typically understand the construction of the house. They don't understand ventilation. They don't understand roof vents. I like to tell them about it. I like them to understand what they're seeing. Here what we have are the two cone-shaped vents on either side of the roof. Those are most likely for bathroom exhausts. The house built in 2012 required that the exhausts were to the outside, and that's acceptable. The square vents that you see at the top, those are off-ridge vents. They're often called roof hawks. You have soffit vents beneath the eave, and the design is so that air comes in through the bottom and out through the top. When you have both the high vents and the low vents, the ratio is 300 feet per square foot of attic space. The round one that you see up there that's rather elevated is a solar powered mechanical exhaust. So it has a fan that's operated by the solar power. The 4-inch vent that we see up there, the tall one with the cap, is for the furnace. Earlier we discussed the water heater. This is larger. It's for the volume of gas, combustion gas exhaust from the furnace. It has the same requirement that it be 2 foot higher than anything within 10 feet. That's not, but again, it comes back to performance of the system. If the heater's working, it's drafting well, that's really not an issue. If we had a performance problem, that's when we would encourage them to raise the height of the vent. Since we survived the roof, we're going to follow the SOP. The next section is the exterior of the house. This is a wood frame construction. We have a combination of masonry. The masonry is going to be both brick and stone, and cementitious board or cement board. This product looks like it's a James Hardie manufactured cement board. I'm going to walk around the outside of the house, and we'll just do a wrap up at the end. I'll make comments as we go, and then we'll wrap up. So we're looking at the exterior. At this time, I'm going to exclude the foundation and the plumbing and some of the other things. That'll be talked about in another segment of the video. We go back to the siding. This is the cement board siding. We see that there's some caulk missing over there. We see the uniform placement of the boards, and again, the manufacturer would like that to be more random than it is. And if you see one that's randomized, it just does look better. We have the section up here where some of the gutter is not. So we have sections with no gutter, and we have sections that have gutters. Over here we have evidence of, well, it almost looks like there's not good drainage. That would contribute to the lack of soil here. We do have the open weep holes. That's important. This is a piece of steel. It's a lintel. It's just a piece of angle iron. And its purpose is hold all the brick up, because the weight of the brick would obviously crush the window. And that lintel should extend out at least 4 inches above this in order to carry the load to the ground. It's often that you're going to see some areas that are cracked. Sometimes they have to notch the brick in order to sit that. For example, I would expect that that brick would be notched. So I would not be surprised to see at some point some cracking there. Likewise, I wouldn't be surprised to see that mortar fall out, as it appears to have done over here. We're in a coastal area where there's basically a lot of salt in the air, so it's not unusual to see this corrode. If you see corrosion, make sure you bring it to the client's attention. Corrosion like that, it might take years to corrode, but I have, at least in one instance, seen this corrode to the point that the brick started moving. Current code requires weep holes above this, as you have there. Current code requires, well, code is always required, that there be flashing beneath the brick and above this lintel, and it come out past so that you can see it. It should come to the surface of the wall. We don't see that. More likely than not, there's some sort of plastic barrier there, but we can't tell whether the ends are dammed correctly. We can't tell whether it comes out, if it's there at all. So in this particular case, it's not going to be repaired. So the question is not, is it there? The question is, do we see some sort of damage that would suggest there isn't flashing and there's water intrusion? So we're looking for evidence of a problem that might be caused by the lack of it. We have what might be ants here in the corner. This is not an inspection for wood destroying insects. You would recommend that they have that sort of inspection done. In my non-licensed capacity, I would tell you that these look like ants. When we have a lintel like this above a large opening, and it might be a garage that has masonry above it, that lintel is carrying an awful lot of weight. And there's some times that you'll see cracks right in the middle near this keystone, and that might suggest a deflection downwards, and it might be just an undersized lintel. Quite often your client is going to see any crack and believe that that means there's foundation problems. There are a lot of things that can cause masonry cracks that are not related to the foundation. You can have walls that shift. You can have the loads just improperly handled. So we're not seeing any cracks there. I don't see anything to worry about other than some discoloration that might suggest early corrosion. This casing around the overhead door quite frequently will deteriorate down here, most especially if it's flush cut or square cut instead of this angle. What the angle does is it allows the water to come down to the corner and drip. If it's flat cut, water will come down here and wick up, and that'll cause deterioration. At an angle, it can also be painted. So you're inspecting that because that's a part of the exterior structure. This is just a missing piece of molding that doesn't have any structural significance. It looks broken there, and down here, that might have actually been cut out. It's a little odd looking. I would report it, but I don't see that as a material defect. Here's an area that you can get close to and see. The manufacturer says that there should be a gap, but says that it should be caulked. And there are some applications where there should actually be flashing behind it. This is an area that we can get to easily and see what I referred to, the leakage that's here. So this is a joint and you have leakage. Hopefully they've sealed it on top, but there was so much of the granules from the roof that I couldn't really tell. This is just a personal pet peeve. That's the address block for the house. They've covered it up for some reason, and then you've got the vegetation that grows. Code actually requires that there be an address block. Now the standards of practice doesn't require that we say that, but the standard defines material as something that affects safety. The purpose of the address block is so that emergency personnel can find the house. That makes it a little difficult. We have the downspout that's installed incorrectly. The downspout should go to the inside of the elbow. They've got it reversed. And that's why you see the scum and vegetation and everything else coming out of that joint. Here we have some siding that's damaged. That siding was installed with a pneumatic nailer, and in a wind load area like we're in now, they do say that the bottom corners should be fastened together. Again, it's to protect against wind lift. But in that area, there was just not enough surface and it caused it to crack. That is reportable as damaged siding. Here you have an expansion joint. That is not a permanently flexible sealant there, and it should have been. There's no give to it, and you're seeing the cracking right there. At some point, someone might look at that and suspect it's foundation movement, but it's not. That's entirely related to the type of sealant that was used. Now, if the weather-resistant barrier is installed correctly behind that, that has no material impact. It's a good idea to test the mortar joints. Using a finger is typically enough. If you have crumbling mortar, that just a simple finger movement would cause to fall out. It was poor workmanship in mixing the mortar. That doesn't appear to be problematic. Because the house moves, you have to make provision so that you eliminate some of the cracking that might happen by normal movement. So we have an expansion joint here, we have an expansion joint there. On a masonry wall, they should be at least every 25 feet. You should not have any more than 25 foot without an expansion joint. These are much closer than that. I think that's fine. The manufacturer of this siding says that you can either face nail it or blind nail it. And this is primarily blind nailed. And blind nailed is your first course. The nails are overlapped by the second course, so you can't see them. You're blind to the nails. In this case, you have some nails down at the lower edges, and in some cases I see that there's some face nailing. That might suggest that they had some loose boards and their solution was to go back and add nails. This is actually poor workmanship in the installation. The manufacturer says that they should be more randomly spaced. It looks a lot better. The joint should be flashed or sealed. In a windstorm area, the manufacturer says that the nails at that lower corner is proper, but that was driven in with an air nailer and just shattered the board. A little higher, about 5 courses from the top, you see that one does not have that nail and is lifted out. The purpose in a wind load area is to stop the wind from getting under there and pulling them loose. We have more damaged siding. We have the gaps much bigger than they should have been. Now, is that gap workmanship or is that gap movement? I don't see any other evidence of movement that would suggest that that is structural movement. So given what I'm seeing and the fact that we have nails in those corners, I suspect that that's just poor workmanship. The foundation should be clear of obstructions that might allow attraction or be conducive to wood-destroying insects. You see right here, well, that looked like something else. I have seen that homeowners will seal those weep holes, and their thought is they're going to keep the bugs out. But I promise you, bugs are going to get in if bugs won't in. Sealing those weep holes is detrimental because any water behind the wall is now trapped and can rise up and damage your framing. If you see them sealed, recommend that they be unsealed. And if the homeowner or the client asks you about it, there are materials that you can put in there that will not stop water. Think about it as steel wool. There are other pieces that are designed to be inserted. You have different dimensions though, so sometimes that's difficult. But those weep holes should always stay clear. Never store stuff against the house. You're hiding those very same weep holes we just talked about, and that would allow termites to infest. Remember that you should be geographically competent is the terminology. And as a part of understanding your environment here, the geography here, we have more termites along the Gulf Coast, wood-destroying insects, specifically subterranean termites, and now a growth of Formosan termites that you want to do everything you can to protect your home against that. Concealing the foundation is just a terrible idea. We see some damage to the siding. It looks like the nails have come out or they've added some nails. We have poor caulk joints. We have openings in the caulk joint. Again, that's not flexible. It looks to me like they used an improper caulk all the way around. Here we have some more separation. Not much, not enough for me to think you have material movement or necessarily that it's movement at all because that's not a flexible caulk. This nail is something that was added by the homeowner. Not a great idea. It's going to corrode. It is corroded. They were probably hanging something from it. You've got a poor finish here. Even the cement board over time will deteriorate if it's not kept painted. And what you're protecting it from is not water necessarily, but it's the sunlight. The UV rays will deteriorate it. We have a cracked board there. Several things can cause that. We also have a little bit of a bow there. Structural movement can cause it, but we're not seeing any evidence anywhere else of that. It could be, well, you see that it cracked right at where it was face nailed. Impact could cause it. And another thing that can cause it, and again, I'm worried about poor workmanship here, the way to install this is you start fastening it from one end and you go all the way to the other end. If you were to start at the ends and work towards the center, you could end with a little high spot there. And in fact, that's what it appears to be, because it's higher there than anywhere else. So it may just be that there was a natural bow there from improper installation. That creates conducive conditions for termites. What we have here is a cold joint. We have the wood that's in ground contact. We have an area that's concealed. You can't get to it. Termites can come from the ground up through into the wood column, and you basically won't know it until you see the damage break out someplace else. We have here that the edges aren't flat, so we have some fastener movement. When we looked at the roof, I pointed out a vent that I suspected was a dryer vent. Over here, I see a number of pipes that come out at the foundation level. We have two over here that are going to be the water heater. The one on the left is smaller. The one on the right then is going to be for the safety pan. The one on the left is the relief valve. That would mean that the flue vent that I pointed out during the section on roof cover was the water heater. This is in that same area. That also means that this other one is more likely than not, we'll prove it out before we're done, but that's going to be a floor drain, which would suggest that the laundry room is on the second floor, which corresponds with the roof vent I saw during the roof section that would have been for the laundry. That would make this the range exhaust, assuming that the kitchen is over here. So we'll look at that when we're looking at the appliances. We have more broken siding. We also have that siding that's dropped a little. A little bit of movement. That means that the nail above it might not have been proper or might not be there at all. Well, actually, and that's because the brick stops here, and that's the first place that's the top plate of your framing. The standards of practice includes windows on the exterior, and for the most part, it's discussing how it's installed and make sure it's watertight. But I'm seeing several of these windows that look like they have failed seals. The upper sash there, I'm not certain that that's a failed seal. It's cloudy. We'll have to look at that closer when we're on the inside. But there are several windows that do look like they have failed seals. And this vent, given that it has a screen over it, well, actually that has two screens. This home was built in 2012. With the current energy code, it is very likely that that is an air intake for a ventilation or dehumidification system. So what we have here is, in my opinion, you have evidence of poor workmanship with the installation of the cement board siding. You have various things like missing vents. You have some of the windows that may be an issue. You have drainage that's not ideal. You don't have any high soil, but they have stored stuff against the house, creating conditions conducive for infestation by wood-destroying insects. Down here, I'm very cautious about that just because of how many wood-destroying insects that we do have. The masonry appears to be fine, though I'm not pleased with the caulk that was used, the sealant, and the same thing around the windows. The caulk just doesn't look appropriate. Will that cause a leak? No, I don't see that it'll cause a leak. Will it cause cracking? Is it material? No. It's just, in my opinion, evidence of poor workmanship. Now that we've inspected the roof and we've inspected the exterior, we're going to look at the foundation. That's the next section in the standards of practice. When you look at the house, it's still standing, so obviously to some degree the foundation is functional. But we're going to walk the perimeter again, and we're going to look at some things I'll point out about the foundation. We'll recap at the end, just as we've been doing, and we'll see if there aren't any foundation issues to discuss. So we've walked this same house before, but we're doing it now for the foundation. First thing I want to point out is this little round patch right here, and there's another one. You're seeing them every 4 to 6 feet. That tells me what kind of foundation this is. It's slab on grade, but what's important about it is the reinforcement. This reinforcement is called an unbonded post-tension cable foundation. And in this greater Houston area, that's just almost exclusively what's used. It's good for the soil type. It's an economical way to have good construction, a good foundation. If you look at the street, for an example, and the sidewalks and the driveways, you see the expansion joints. So what they have done is they've created smaller sections of the concrete that can move. But you can't have an expansion joint here in the foundation. So what you have instead is you have to have a way of taking tension out of the foundation, which is weak, and putting it in compression. Compression is very strong. So they have a series of tendons that after the concrete's cured, they pull it. And it's the equivalent of about a 30,000 pound anchor hanging off of that tendon. And that tensioning causes compression in the concrete. And that's what gives it its strength. Here in the corner, we have a crack. Many clients will look at that and go, oh my gosh, we have a broken foundation. That's a shrinkage crack. There's more surface area at this corner than anywhere else because you have a surface, and you have a surface during that curing process. And that concrete, which does shrink, just shrank a little bit faster than everything else, causing that corner pop. Extremely common, and it's not a concern. If a client has concern about it, I usually describe it as a casserole or a cake being cooked in a square pan. What happens to the casserole? What happens to the cake? The corners get hard. It's the same thing going on here. More surface area, the water cooks out quicker, and the corners get hard or crack off. There is a brick crack there, but it doesn't appear to be related to anything structural. No cracking. When we're looking at foundation, it's also important to look at the freeze board. If you see separation on the freeze board, it could also represent movement, but we're not seeing anything there. Another freeze board, no movement. Not required to move all this. Yes, there's a possibility that that's hiding something. If I were doing this inspection to write a report on this, I'd take a photograph of it to show that I did not have visibility. But there's no cracks anywhere else, so I think there's minimal risk of a problem. I would just document that there's an area I could not see. I'm scanning the masonry and the slab at the same time, so that's why I'm looking up and down just as if I were doing this as any other exterior evaluation. Drainage, which can affect the foundation, and we talked about that during the exterior, which is where it falls in the InterNACHI Standards of Practice, has the potential for a terrible impact on your foundation. And you have poor drainage right there around the electrical box, around the gas meter. In this particular case, this patio has been poured after the fact. This is not a part of the structural foundation. And in this case, you have about 1 inch clearance, maybe 2 inches of clearance where you can see the foundation. Many times it's built up higher and you can't see any of the foundation. Be sure you document that you can't see a portion of it. Now, I can see the foundation. I can see that there's no cracks. I can see there's no cracks in the masonry. We'll operate the windows later to see if that has an impact on the foundation or if the foundation has had an impact on the windows. But if you can't see the foundation, document for yourself if nothing else, that there's an area that you could not see. There's no cold joint here. That means this foundation piece supporting this was built as a part of the house structural foundation. Likewise, there's no control joint there. So that means all of this was poured monolithically with the house. So this is the third time we've walked around this house. And if I were doing this as my own inspection to document it, 3 times is not unusual for me to walk a house because I'm focusing on different things each time around. There's nothing on the outside that says there's a problem. My inspection of the foundation is not complete though. There's more that I do inside. I'm going to look at doors and windows to see if they bind during operation. I'm going to look at the floors to see if tiles are cracked, if tiles are separated. I'm going to look at the drywall to see if there's any separation cracks or anything. I'm going to look in the attic to see if there's any movement from the rafters and the ridge board. There's a lot of things to look at other than out here, but I'll tell you that with what I've seen out here, I don't suspect that we're going to find any additional evidence or signs of movement that will cause concern. The heating and cooling sections are separate for the standards of practice, but realistically, you're going to be inspecting both things at the same time. You cannot operate a cooling system if it's below 65 degrees according to the standards of practice for InterNACHI and 60 degrees according to the standards that I follow. There's some HVAC companies that say 55 degrees, but remember, following the standards of practice is your protection, so you don't exceed the standards. If it's below 60, I don't test it. And coincidentally today, as rare as it happens, it is below 60 degrees. And it was as cold as 32 degrees, so I'm simply not willing to test the system today. And I do explain that to the client in the winter when there is a risk that I'll not be able to operate the system. It's important that they know your limitations and they don't want to feel that you've tricked them. So I can't operate the cooling system today. I can operate the heating system because it's a gas system. If it were a heat pump, I have limitations on operating the system if it's too hot, and the heat pump can't operate if it's too cold. Then you'll have electric heat strips. But in this house, we have natural gas for the heat. I won't be testing the unit, other than I did inspect the outside unit. I determined its age, 2023. I determined its size, 4 ton. That's not necessary to report to the client, but it helps you understand the system as you're doing the inspection. For example, a 4 ton unit should have at least 640 square inches of filtration minimum, and the recommended is 800. So it's a good idea to know whether the filtration is adequate for the size of the unit, because if it's not, you're going to have performance issues. I look at the supply air registers. Now, when I'm doing my inspection, I'll use a thermal camera as I'm taking the cooling readings. I'm not just looking for heat loss. I'm not looking for missing insulation. I'm not looking for leaks, because you have performance issues around these supply air registers. A lot of times you'll have condensate buildup that causes mold to grow. So that register should seat very tightly against the ceiling. And I see both of these have gaps. Now, the air loss that I suspect we'll see there is simply between the supply air and the return air register. There are some times that you can have a gap between the ceiling and the boot. And if you have that kind of gap, you're drawing air from the attic into the room, and not only are you going to have possible condensate, but you're going to have dirty condensate. So if you have something like that, what you could recommend is cleaning those, building a gasket around the plastic, or just referring it out to an HVAC company. Now, another thing that's interesting to note is that in this climate, specifically here along the Gulf Coast area, the supply air registers should blow towards the outside wall. Now, that even is if the supply air registers are located right here, because you have to take the air off of that wall in order to recirculate it. Otherwise, for example, the registers were here blowing that way. this air could stay hot. It wouldn't circulate through the filter, wouldn't cool down, and you would have an uncomfortable zone. So be sure you look at the fit of the supply air registers and the direction of the supply air registers. That one looks correct. Let's find one that might be, no, all of these are set far back. They're all facing the outside wall. Just a comment for you. When I find them that are backwards, there's a couple of things. It's unlikely that the installer did them all backwards. Check to see if they've recently painted the ceiling, because sometimes they'll be taken down and the homeowner will think, well, this is the direction they should face. But when I find them backwards, more often than not, I find that there's a performance issue that the homeowner has tried to fix by turning the register, because they say, oh, look, I'm not comfortable because it's not blowing on me. So if you see a lot of them that are backwards, suspect performance problems, and you might even find that the AC has recently been replaced, because after a while they determined that that wasn't enough to solve their problem. They called somebody and replaced the AC and didn't turn those back around the way they went. We've discussed the fact that we can't test the cooling system because of how cold it is. So we're going to test the heat system next. The thermostat is located here on the second floor, 2-story, 1 HVAC system, but only 1 thermostat. That means the downstairs temperature is going to be regulated by the upstairs thermostat. There are ways around that, but we're not here to teach the customer anything about that, the client anything about that. So just recognize you're required to say, here's where the thermostat is, top of the stairs. We're not required to operate programmable thermostats, but that's about the only way that you can operate this system. This one is currently set to off. Document where you find it. The first thing I do is I take a photograph. I'll go ahead and do that. The purpose of my photograph is to show the mode I found it in. So I'm going to skip cool. I'm going to go directly to heat. It's set to 69 degrees. I'm also going to take a picture of that, and it's on hold. So when I'm done, I return it to heat at off, but heat at 69. I'm going to raise the temperature from 69. I don't have to raise it much because it is pretty cold in here. So here's our gas supply line. You can't see it from where you're at, but there is a sediment trap, as there should be. The pan here, it's well worth moving just to see if that's stable or it's going to rock or tilt or in some manner collect water that it can't get rid of. And then right here is the vent that allows you to put, most people say bleach, I say vinegar. The vinegar is going to have less of a detrimental impact on the evaporator coils. And that water would run, the condensate would run all the way down to the underside of that sink that we discussed in the hall bathroom. So manufacturers typically say a couple of times a year. I translate that into quarterly. If you put some vinegar in there, it'll keep that algae from accumulating. The evaporator coil's got no moving parts, and the date on it is 2020, which is the same as the outside unit. So those were replaced together. I haven't opened this up to determine what its age is. We're not required to determine whether the outdoor condenser and the indoor evaporator match. So we have the heating equipment here, and it's important to note that the flue pipe is secured so it can't move. What happens often if it's not secured is that during re-roofing it might get displaced and might have direct contact with the roof. But this does have a strap across it. There is no contact. The vent is intact. It's supported the way it should be. So I think we're in good shape there. Now what we'll do is remove the cover. Some covers, you have to remove both halves of it, and it's got a safety interlock. And what happens then is you remove the cover and it shuts off and you have to put half the cover back on, but this one doesn't have that issue. Okay, now with the cover off, Amana and Goodman are pretty much the same. It's just a different brand from the same manufacturer. So all of these units are 2020, so they were replaced all at the same time. I don't really like this. They have a protective grommet here, or bushing, to keep the metal from rubbing that, but I would rather see it be clamped in place so that you don't get that sort of movement there. When we're looking at cooling, we're looking at the difference between the air temperature at the filter, the return, and the air temperature at the supply, which is the registers blowing air into the room. And that should be between 15 and 22 degrees. When you're looking at the heating system on a gas system, what you're really looking for is the performance of the fuel-fired system and the draft. That should be good, clean blue flames. You don't want yellow, white, or red, and you don't want the flames to be flickering back and forth. That is a good, clean blue burn flame, and I'm not concerned about the height of the combustion flue above the roof. This looks good, no problems with it. When we were downstairs, we saw that the return air grills did not have filters. And in fact, the grills were not designed to accept a filter. And I surmised we would have a large media filter upstairs, and there's the housing for it, but we don't have any filter installed. Now we don't know how long it's not been installed, but I guarantee that all the air bringing all the dust, since that filter's been removed, is now accumulated in that coil. And if I were able to evaluate the cooling performance, I think we would see some deficiencies. This needs to be serviced and those coils cleaned to reestablish proper performance. Now, if you look right here, do you see all that dust? That's just an example of what we would expect to have accumulated on the coils now. This system has been treated poorly by operating without the filter. It now needs to be cleaned. Now that we're out of the attic and we're wrapping up, it's important to put the thermostat back exactly like you found it. So we found it off and we put it back to off. Personally, I take a photograph of that to prove it. You can cause problems leaving, especially in a cooling mode, if you leave the thermostat on at the wrong temperature. So take a picture, that just protects you. You don't have to put it in the report. This is the guest bath. But what I want to show you under here is that there is this black hose right here that is the primary drain line for the air conditioner. So all the condensate created by the running of the AC will run through here and drain. Now, between this point and the air conditioning system in the attic, algae can grow because of the stagnant cold water. But right down here you have a trap, and the hair clogs from using the lavatory can cause that. So if it backs up, we'll see that when we're in the attic looking at the pan. Just, you need to understand that where this drains, that sink and the trap needs to stay clean. As a part of the heating cooling system, condensate is formed during the cooling process. And the primary drain is going to the lavatory in the hall bathroom. And then it goes into the safety pan if there's a backup there. If it comes into the safety pan and drips out here, you'll notice it's right in front of a window. The intent is, as soon as that starts dripping, somebody's made aware of it. Houses are not intended to drip. If it's dripping from there, it's an AC problem. If it's dripping from the two pipes on the side, it's a water heater problem. If it's dripping from the larger pipe, it's a washing machine problem. Houses are not intended to drip. Drips means there's a problem. The heating cooling system is made up basically of three components. You have the outside condenser. Some people improperly refer to it as the compressor. Actually, the compressor is causing the condensing of the refrigerant. And then you have the upstairs evaporator. So the condenser in conjunction with the evaporator cause the cooling. Then you have the heating system. The heating system can also be referred to as the air handler because that's where the fan is. The fan blows for heating or cooling. And it's just either pushing hot air or pushing the air that's removing heat as part of the cooling system. This condenser is mechanical equipment. Even though it's not a code inspection, the code says that this should be anchored down. And it's without regard to whether it's a windstorm county or not. I don't see it enforced down here. I call it out regardless because Wind will pull it. Now people think it needs to be anchored to keep it from being stolen, but it's to keep it from being damaged in wind. This was installed in 2020, and in 2020 it already required UV wrap on that insulation here. That should have a wrap to keep the UV from damaging it. And in addition, these caps there for the refrigerant should be tamper resistant. So we have an AC that was replaced, and let's just assume it's functional. It still was replaced without bringing it entirely up to code. And I would typically bring that to the client's attention. What's the problem? Well, that insulation might cost $5 to replace, and it might not concern them, and it's certainly not negotiating for it. But it's just nice to know that whoever did it, there was poor workmanship. They did as little as they had to. But in the windstorm county, that should have been anchored down. As a part of the plumbing standards of practice, we're required to describe to the client where the water meter is. This is the meter between two houses, and you'll notice it's got two sensors, so that 1 meter box is taking care of both houses. If you're ever confused about it, what you need to do is remove the lid, clean off the display, and then go turn on the water to prove you've identified the proper meter. We're also required to report the main shutoff. Older homes might not have a main shutoff, and you need to report that as a deficiency because the homeowner's not going to easily be able to turn off that valve at the meter for winterizing or any other problems. This is the shutoff. 90 degrees, if it's perpendicular to the pipe, the valve is closed. We're required to show pressure. Now this is a simple water gauge, and the problem is they can become out of calibration. That one shows 60 psi. For the purpose of this inspection, that's perfectly fine. I'm looking for between 40 and 80. If it's below 40, you might not have good flow. If it's above 80, you might start popping seals, gaskets, washers, etc. Also, as a part of the plumbing system, we need to describe where the gas shutoff is. In this particular house, I would have shown that the water meter was at the street right-of-way on the left side of the house. The shutoff was on the left side of the house at the front corner. And in this case, the gas meter is on the right side of the house immediately behind the fence. That's adequate descriptions the homeowner could find it. There is a bonding clamp for the gas pipe. As a part of the electrical system, we're supposed to report deficiencies in the bonding and grounding. Now, we can only guess that that grounding conductor goes over here to the panel, but it's not expected that it would not, so that's a good assumption. But what I see down here is this cable coming out of the wall has been cut, and this cable is not connected to anything except it is a part of this grounding system. So that means whoever installed the switch for the generator has disconnected the ground. This is an ungrounded system. That has to be fixed. It looks like they had every intention of grounding it, and they just didn't. That's a deficiency that must be fixed. This water heater has a blanket installed over it. Some manufacturers will void the warranty on the water heater if a blanket's installed, and that's because it hides the label, number one. It also can conceal damage occurring to the water heater. That water heater is insulated well enough that that really doesn't add much value to it. I can't get to the water heater label without damaging the blanket. My client does not own this house, and I can't damage that. I might not think it has any value, but that doesn't matter. It's here, and I can't just start ripping it apart. What I can do is look at this relief valve over here, and I see the date on this relief valve is 2010. Well, that's 2010 on a 2012 home. Well, it's not out of the question that they could have taken one of these off the shelf. It happens. But now what I have is a 12 No, I have a 15-year-old valve. The manufacturer of that valve says it should be tested annually and replaced every 3 years. So if I have a valve that should have already been replaced 5 times, I'm not going to come over here and test it now and risk that it doesn't reset. There are some inspectors who won't test it at all. I say you need to make a valid judgment on every single water heater. If it's less than 3 years old, in my opinion, there's no reason not to test it unless you cannot determine where that discharges. Remember, our function is to discover problems, not cause problems. So if I can determine that I can test this without water leak, then I should test it. If it's too old, then I should not test it, but the recommendation would be to replace that. The fact that it's 2010 makes me concerned that this water heater is also 15 years old. We're not required to determine the life expectancy or remaining life on any appliance, but you'll find that the client is benefited by knowing that they're buying a 15-year-old water heater and should not expect it to last much longer. You have a dishwasher. You have to have a configuration that will prevent water from draining from this sink back into the dishwasher. Here we have an air gap device, and this device is designed so that water, in fact, let me just disassemble it here, so that water comes up out of this tube under the pressure of the dishwasher pump. It hits this cap and drains by gravity. Well, quite often it can push debris up, but the debris won't fall and it gets stopped up. When that happens, it comes out here, and this cap is intended to direct water here. I've seen many times that people turn it this way because they don't want to see that ugliness. But then what happens is if it ever backs up, it goes onto the countertop, which just makes them angry. So they come down here, and lo and behold, they did exactly that. They have bypassed the original drain, and they've simply gone from the disposer down to the dishwasher. And then over here, all right, they abandoned this, but they did create an adequate hose loop. Right here goes up to the center of this divider. So it looks to me like somebody did not understand the purpose of the air gap, didn't understand how to clean it, just bypassed it, but they did accommodate for eliminating it. We also have a reverse osmosis system down here. I exclude that. There's not much that we can test on it other than, hey, look, water comes out, must be working. I've been doing this for 20 years. And because of that experience, I'm able to identify a bathroom probably 99% of the time. This looks like a bathroom to me. We have 2 lavatories, we have a tub and a shower. The standards of practice that I follow and that InterNACHI has is that we have to run at least 2 fixtures at one time to evaluate the flow. What I personally do is turn on every fixture in the primary bathroom, because usually they're going to be at least 2, usually 3, and most often 4. In this particular case, the weather stripping is damaged at the bottom of this door, and that can cause water loss. Report it. You don't care whether they replace it, but you really should report it because that can cause water to come out. And then let me turn on this one last fixture. Okay, so when I document my inspection and I discuss water flow, what I say is that I operate every fixture in the primary bathroom simultaneously. And that way I don't ever have to decide whether I did 1, 2, 3, or 4. I know I did every one in the primary bathroom. And what you'll see here is that I'm running every one of these 4 on hot. If you have a problem in water distribution, usually it's going to be on the hot water side, especially as the hot water tank gets older and it builds up the calcium deposits. The functional capacity gets smaller. You run all of these at once, you're going to have a better idea, not just of the performance, but whether the recovery rate is adequate. Because you test all of these, and then you go to test others and you find perhaps they're not as hot, then you still have a problem with an old water heater, and it's how long it takes to recover. While these are running, you look underneath the sinks. What you want to look for is evidence of existing leaks or previous leaks. And you see right back there a little bit of blistering. Down there a little further. See a little bit of blistering right there? So that might have been a leak at one time, but never much of a leak. It could just as easily be some of these liquids spilled. They have another filter in here. I'm surprised to see that filter. It might be that this homeowner had some particular problem or just desire to have that be filtered water. This is CPVC water pipe. Insurance companies will often want to know exactly what kind of water drain pipe and water supply pipe you have, because if this were an older home that had never been updated from galvanized pipe, the risk of a supply pipe failure is much, much higher. So we didn't have any problem with distribution of water. The drain stops work, except that one didn't work. It's supposed to be connected, obviously. That would be a reportable deficiency. The water we're seeing is clear. We have hot from the hot side, cold from the cold side. These single handle manifolds sometimes will be reversed. So it'll go, instead of cold to hot, it'll go hot to cold. That is repairable without removal of the wall, and it is reportable deficiency. This window should be safety glass. Again, InterNACHI standard doesn't require that you report that, except that it is a safety issue. So I would report, this one is, so I have nothing to say there. Because that window doesn't open, this bathroom has to have mechanical exhaust fan, and it does. And that mechanical exhaust must go to the outside. That is since 2006. When we were outside looking at the roof, I pointed out 2 vents that I expected to be bathroom exhaust, and this is right where one of those was. So I'm pleased to see that. The bathroom toilet closet also has an exhaust fan. The purpose of this one might be odor, but the purpose of this one is humidity, and that makes this critical. And I always encourage my clients to use the exhaust fan during showers and in tub baths. It's important to make sure the toilet is not loose, and I just sort of straddle it and move my legs. We're also, under both standards of practice, required to look at the assemblies there to make sure that they're intact. It's also very important that this hose does not go into the water. I have personally found blue water coming out of a tub faucet because of tidy bowl. So that means the water was traveling through this tube into the potable water and coming out the tub faucet, which is kind of gross when you think about it. I take pictures of that lid off and the picture of the assembly. I can prove then that I did it, and the act of taking the picture puts me in the right place to prove the toilet doesn't wobble. Laundry room. Now, I don't know what order you're looking at these videos in, but outside I surmised that the laundry room was on the second floor, and I surmised that there was a safety pan. And if you look right there, you see both the safety pan and the fact that we're here on the second floor. What we can't do, however, is tell whether that drain line is intact or functional. The only way to do that would be to fill it up with water, and that's way outside the scope of any inspection that we're going to do. Today's world, these 120 volt receptacles would also have to be GFCI reported. Change of code, but I'm still required to report that under my standards of practice. Another thing to note, and we have two things here. One is my standard requires that I report whether this is GFCI protected or not. But the other thing is that you'll notice this has 4 prongs. This is a 240 volt grounded receptacle. Prior to 1996, or 96 and before, this only had to be 3 prong. You would have the neutral and the 2 hots. It's just safer now, but this also has to be GFCI protected. I go to the trouble of telling my client it's 3 prong or 4 prong and finding out whether they're bringing a washer and dryer with them, because many times they'll bring a dryer and it's got the wrong kind of cord. It's very easy to replace the cord and only costs about $30, but a lot of times, not a lot of times, but I have seen that the homeowner has replaced that and now you have an ungrounded receptacle. So just tell them it's 4 or 3 and try to find out whether they're going to bring one or buy one. This one also has gas available. There's the gas valve and plumbing right there. A lot of clients want to know whether gas is available. Easy enough to tell them when you see it. Has an exhaust fan. Encourage them to use the exhaust fan. There's going to be just as much humidity during the drying and washing process as taking a bath. You've got to get that humidity out of the room so you don't create mold and mildew. We're going to look at the electrical system now. This is an underground service. It goes into the meter. From the meter, it goes into, well, they have changed it. Originally, it went directly into this box, but they've capped the knockouts. And now it goes into this Kohler automatic switch for a generator. And from the generator, it comes through here. We have a Kohler generator switch box. This is an automatic switch so that when power is lost, the generator comes on, and from here it feeds the distribution panel. We're not going to talk about this generator. That is a course and class all by itself. I would suggest to you, though, you don't even pretend to inspect a generator until you're educated enough about it. Most of them are locked. There's information that you certainly can get off of it. Just don't make a mistake and pretend that you understand this. Which brings us to the original disconnect. Now we're supposed to describe this system. This is a square D panel. The purpose of describing the system is there are some problematic panels out there. This square D is not considered to be one of the problematic panels. If you have one, the most common is the Federal Pacific Electric stab lock. You have Sylvania, or you have the Zinsco, and you have the Bryant. Those have known problems, and insurance companies might balk or at least raise the premium for insuring the home. These devices are arc fault breakers. Arc fault breakers are protecting against, this is really crazy, arcs that can cause fires. They were introduced in homes in 2002, and today many of these, if not the majority of these, are going to be arc fault or combination arc fault and ground fault. This home is occupied, and in an occupied home I will not test the arc fault devices, because if there's a computer there, if there's a TV there, if there's some electronic appliance there and it stops working after I test that and reset it, as far as the homeowner is concerned, it's my fault. So in an occupied home, those will not be tested. Otherwise, testing is as simple as pressing the button that says test, and then resetting it. It should trip and it should reset. If it does neither, it needs to be replaced. It is a safety feature. And in the standards of practice, something that's pertaining to safety is considered material. It's also important that the box be labeled. You can't determine if it's labeled accurately. Sometimes you can see it's obviously inaccurate, but you don't know about every single one of the breakers. These that are oversized are 240 volts, and you see that this says air conditioning. If it's labeled, I can compare that breaker size to the demand or to the manufacturer label on the other product. The 4-ton Goodman AC unit over there requires 30, so it's good. The dryer is 30, that meets code. The disposal and dishwasher is not because it is a 240 volt disposal or a 240 volt dishwasher. That is on a single breaker so that it's impossible for one to be hot while the other is live. The receptacles might share a gang box down there, and if you think one half of it's dead, you reach in and grab the other half, you can get injured or killed. That simply makes sure that both are off if one is off. You have a 125 amp main breaker. The label for this box is on the inside that would tell me what its capacity is, but I'll tell you, I'm familiar with the box and it's 125. So let's take the cover off. We have a plastic raceway, so I don't have to worry about bonding that lug there. You can see here that used to be where it had a metal raceway, and they've capped both of them properly. If you have any penetrations in this box that are open and not capped, you should report it. You don't want mice in there, rats in there, lizards. You don't want anything in there that can gnaw or just cause other problems. You have copper service lines. You have copper branch lines. Insurance companies generally want to know that in older homes. Aluminum or branch circuits are problematic. There's nothing wrong with having an aluminum service conductor. The breaker size needs to be adequate for the wire size. This is number 10 for this 30, that's proper. This is 12 for the 20, the rest are there. This is much larger than it needs to be for the 30 amp, but I noted that the air conditioner had been replaced. So it looks like the newer unit, more efficient, needed a smaller breaker, and that does look like it's been replaced. So there's nothing wrong with having the oversized wires. The problem is undersized wires. This looks like there might have been some moisture in here. Can't tell whether it was a leak, or if it was just maybe high humidity, condensation, etc. Does not look like it's caused a problem. The cabinet is bonded. Down here you have the grounds that are attached directly to the cabinet. Now, this is a sub-panel to the disconnect. That's important to know, because the sub-panel, the grounds have to be isolated from the neutrals. And I sit here and look at it, this is much shinier, so it looks to me like they added this ground bus bar at the same time that they added the generator and the automatic switch. This looks good. Since I eliminated testing the receptacles because I don't have access to the resets in the garage, pretty much we're done outdoors. The other electrical items would be smoke alarms. We'll look at those when we're indoors. And it would be the GFCIs for the bathrooms and the kitchens. Current code requires that every receptacle serving the countertop be GFCI protected. Not only that, but the way the code reads now, beginning September 1, 2023, is this receptacle has to be GFCI protected. This one has to be GFCI protected. The disposer has to be GFCI protected. The microwave, range hood, and cord for the oven have to be GFCI protected. Those are changes of code. My standard requires that I report that just to alert the homeowner that there's a safer way to do it. In this particular case, I would report that they're not GFCI protected, but I'm not making a recommendation that they bring them up to code. Now we get back to that 3-light tester. This is a GFCI, that one's a GFCI. I can tell that just by looking at it. But over here we have a receptacle that is not a GFCI. So it should be downstream of one that is. I push the button and I find a third GFCI. Code requires that there be at least 2 circuits that are two GFCI protected circuits. So we have here 3 circuits. There's nothing wrong with that. There are at least 2. They do it by 3. So all of the countertop receptacles are GFCI protected. Now there's another standard that says any receptacle within 6 feet of a sink basin, a tub basin, a lavatory basin needs to be GFCI protected. We have this receptacle that is within 6 feet, even though it's not in the kitchen, and I test it, and it is not tripping. Therefore, that one is deficient. It's within 6 feet of a water basin and not GFCI protected. I would have them replace that. Beginning 2005, code began requiring a tamper-resistant receptacle. A tamper-resistant receptacle will not allow you to put a single blade, think of it as a fork, think of it as a knife, into a receptacle. So I can't do that. But what it will allow is 2. So that is a proper tamper-resistant receptacle, as is required now. I am required under my standards of practice to report it as deficient if it's not tamper resistant. It doesn't matter if the house was built in 1950 and there was no such thing, I'm still required that report it as deficient. During the test to decide whether or not this type of thing was required, they determined that 100% of 4-year-olds could pull those little plastic child caps off. So that's when this was developed. This receptacle, also in this primary bathroom, needs to be GFCI protected, and it is. But we are required on the standards of practice that I follow plus InterNACHI that we report the missing receptacle. And that's smart because there's too many ways to get something in there that could cause you to be shocked. Always reset the receptacles or the GFCIs after you test them, because the seller might not even understand the location of them. And as far as they're concerned, the home inspector broke it because it used to be hot and now it's dead. This is the guest bath. And this one has a dedicated GFCI. Sometimes you'll find that a homeowner added a GFCI not understanding that it was protected upstream by another one. So sometimes you won't be able to reset this one until the other one is reset. I'll go and test it because it's very easy to do. We see that it tripped and it reset, so we know it's not an issue. As a sleeping room, it has to have a smoke alarm. Now the smoke alarm is a part of the standards of practice under electrical. The alarm has a lot of requirements and restrictions. It can't be within 4 inches of the wall. It can't be within 4 inches of the ceiling. It can't be within 3 feet of a return or a supply air register. It can't be within 3 feet of the outside edge of this fan. So that one is okay. I personally don't like it when it's installed just above the door. So I tend to see and recommend more that they're over here. Post-construction, because the placement of these alarms is 1996 and newer. Post-construction in older homes, you can use battery-powered alarms. And in fact, they have wireless alarms. If one goes off, they all go off. Much more expensive. They cost over $100. But that way, you could have a children's room or a child's room, and you'd be alerted to it in the primary room. So the placement of that is okay. This one is a combination smoke carbon monoxide. That is not required in a sleeping room. Only a smoke alarm is required in the sleeping room. Now I have another ladder, just a step ladder, that would allow me to get down here and take that off and look at it. They have a lifespan. The lifespan on that alarm is 10 years. Since it's a combination alarm, I doubt it's original, but I would prove that out as a part of an inspection. You're supposed to have another alarm immediately outside the sleeping room, and then you have to get into the definition of what is immediate. Well, remember, it can't be within 3 feet of a bathroom door. It can't be within 3 feet of this return. So this area will not allow an alarm. So they put it out here, and this is as close to the immediate area as we can get. Just barely 3 feet there. So you're not going to do anything about that. I wouldn't ask a homeowner to do anything about it. I think it's poor planning, but it's okay. This is also a combination alarm. And since this is post 96, this should make all alarms go off. And it does. This is another combination alarm. A lot of discussion about where the alarm should be. A combination alarm with a carbon monoxide alarm up here, or detector, is perfectly acceptable. The gravity of oxygen versus carbon monoxide is very slightly different. So that's perfectly acceptable. I know that some say it has to be down here. That's not the case. This is perfectly acceptable. Now here's another alarm. And frankly, that alarm, I wouldn't consider it to be required. But because I can get to it, I'm going to look at it. (2020). So this alarm has been replaced. Had it not been replaced, it would be 2012, 2022. It would be a 12-year-old alarm, and I would report that as deficient. I am noticing that they replaced everything so far with combination smoke carbon monoxide. No fireplace. If there were a fireplace, it would be inspected to the limits of the standards of practice. We would not be able to see above the throat. We couldn't see into the flue, but we could look at the fire box. We could look at the hearth extension, gas wands, etc. In this particular case, there is nothing to inspect. Access to the attic is a part of the mechanical system. It's part of the code for mechanical. It's a part of the standards of practice because you have to get to that equipment that's in the attic space. So that means any issues with regard to the stairway can be recorded in several places. I'm hearing an alarm upstairs, so we'll have to figure out what that is. Important to know is this is an insulated door. We're required to report missing insulation. That door is required to be insulated today. It doesn't have to be fire rated in this application. This door is rated for 350 pounds. Code does not require 350 pounds, though my local authority having jurisdiction does require 350 pounds. I recommend that, especially if you have an older ladder that needs to be replaced. Minimum is 350. I'm 200. I'm a lean 200, but I'm 200. So if I go up that stairway carrying 100 pounds of equipment, 250 just won't cover it. You want to make sure that all the hardware is intact, that there's no loose hardware, that it's not cut improperly. All of these cuts, all of these joints should be flush. It should be left flush on the ground. And if it's not, then you just have a weaker stairway. In this particular case, we have this boot that's been installed to keep insulation from falling in, but it is also an insulation feature all by itself. Personal opinion, those are unsafe because you're having to stand at the top of this stairway open it, and now you have to climb over that. There's enough danger in getting into the attic without having to step over that. Now there is a code requirement that says there should be something to keep all that loose fill insulation from falling over. You just have to, maybe I tell them it's supposed to be there, but it's dangerous, be careful. This is the certificate for the insulation that was installed. That is required now as a part of the energy code. Now, interestingly enough, nobody's bothered to fill out the certificate. So it's like if we were going to do it right, we would post it right here. They've also come in here and covered all of the insulation with this radiant barrier like we saw in that other attic space. Now that means it's extremely dangerous to try and walk anywhere off the side of this. So we're not going to be trying to do anything other than inspecting from this area. The radiant barrier that they've applied here post-construction, it hides the joints, it hides the studs. So I'm not able to determine where a joist is, and it's very dangerous to try and walk off that. So we're going to do all of our inspection from right here. We're going to turn first and look at the ventilation. I see the flexible exhaust duct over there. That is consistent with a laundry room exhaust and a bathroom exhaust. And because of its location, I can tell that that is the laundry room exhaust. And then you see to its left the rigid vent that goes directly through the roof. That rigid vent is the dryer exhaust. So the vent that I surmised on the roof was for the dryer is in fact for the dryer. Since our movement is restricted in this attic space, and frankly even without the radiant barrier there, I'd be very cautious. But that doesn't exclude us or excuse us from inspecting the rest of the attic space. We just recognize we can't inspect it from anywhere other than here. So make sure that you have adequate, powerful enough flashlight that you can see the areas you need. What we need to see is areas like this, where the rafters are meeting the hip board in that particular case. There's a little bit of separation, but it could just as easily be workmanship. I'm not seeing anything that says it's a pervasive problem, so I really don't think that's a workmanship issue, but neither do I see any problems from it. So over here, we see that the flexible duct is going to that cone-shaped vent on the back side of the house, just like we surmised. We see over in the corners of the eaves, we have the black plastic baffles. That allows air from the soffit vents to come up above the insulation that's blown in to ensure that we have full and proper ventilation. And it seems to be continuous. We're good there. Somebody has taken a lot of care to put all of this radiant barrier down. And if you look right there, there is the solar-powered mechanical vent that we discussed, and it is running. Now, the standards of practice does not require that we operate it, and for the most part, you can't get to them to operate it. So how do you know that it works? Well, frankly, you don't. But if it's 100 degrees outdoors and it's not running, I believe it's not functional. What you're basically going to do is say, hey, homeowner, you've got an exhaust fan there that's not running, and I really believe it ought to be. This is attic access. If you have an attic space more than 30 square foot with 30 inches of headroom, you have to have access to it. This door is adequate, even though it's not a full height door, it's adequate. In here, they've put a radiant barrier post-construction, and that was probably to keep this area a little cooler than everything else since they are storing stuff here. But you'll also see a radiant barrier that was a part of the original construction. That kind of radiant barrier is purported to give about an 8% improvement in energy performance. These are windstorm straps. It just depends where you're located, whether you have one on every stud, you have many, you have few. We're not doing a code inspection, we're not doing a windstorm inspection, so there's nothing to say about it other than, hey, I see it, because a lot of clients don't understand its purpose. During your inspection, if there's a door, you should open it and you should look into it. Especially you have a second floor, who's to say you don't open this door and find water damage in the ceiling? You should not have bare bulb fixtures in clothes closets. Now, in this particular case, you have a globe, and the idea is you just don't want anything stored there, especially clothes, to fall over and touch the bulb where they might cause a fire. You need to make sure you look at doors and windows for moisture intrusion. Missing weather stripping can cause moisture intrusion, typically during wind-driven rain. Windows, the same thing during wind-driven rain. I use a thermal camera, I'll show later, to see if there's any issue. Over here, we can surmise that somebody at some point had a pet and they wanted out and didn't know how to use the doorknob. I'm reluctant to shut this door because I don't want to lock myself out. There's not a doorknob. They have changed that. So you might want to be careful about shutting any door that you might get locked out. Linen closet. And clothes closet. Light did not come on. Inspecting this room, I would test every single receptacle and I would test both windows. I say every single receptacle that's acceptable, accessible without me having to move furniture. We're going to open a few windows, a representative number of windows that we can get to. Not going to move furniture, not going to risk breaking anything. My standard would require not a representative sample, but every window that I could get to. These are double pane windows. So we're looking for failed seals. Remember that I said we would look for binding windows and binding doors when we were inside inspecting the windows. This one opened very smoothly. There is an alarm contact that has been drilled into the windowsill. And you see that that's right next to the sign that says, if you drill into the windowsill, it voids the warranty. There's nothing to do about it. It's already been done. It's gone. I just recommend to my clients they make sure that this stays caulked just to prevent water intrusion. And then here in front of the window, on the window stool, this is the stool, we see a little bit of swelling, which would indicate moisture, but it's not here. And most of the time that moisture would move this way. That doesn't appear to be water intrusion. I'm not sure what caused it, but I don't see it as a leak. Try to put the screens back just like you find them. In fact, anything you move should be returned to the way you find it. Same thing, we have the sill that has been drilled for the alarm contact. And we have the label that says don't do that. And something else that's interesting to see is that we have a wireless alarm contact right here. Now the standards of practice say we're not inspecting low voltage system, including alarms. That just tells me that an alarm system was installed post-construction and they didn't utilize the original wired contacts. And even though I'm not going to open this because we've described it, I am looking to see if the seals had failed. From the outside, there were several windows I was concerned about. No evidence of a failed seal. No staining, no failed seals. We have some dirty caulk joints here, but I'm not able to tell if that's housekeeping or high humidity. This was one of the windows I was concerned about it being a failed seal. It's just dirty. This window is more than 24 inches from the door, and therefore it does not have to be tamper-resistant glass. The standards of practice for InterNACHI says that you're not inspecting for tamper-resistant or safety glass. My standard of practice requires that. But remember, the InterNACHI standard does say it's material if it's a safety issue. So I would still report that as deficient if it were not safety glass and it were within 24 inches. When we're inspecting a sleeping room, one of the most important aspects of it is emergency egress. These windows have to be at least 5.7 square feet so that you can get out and that a fireman could come in wearing his backpack. This window meets the requirement, so that is acceptable as an emergency egress. I do point that out to my clients so that they don't end up blocking the windows with furniture, eliminating the emergency egress. We have a crack here. This is called bullnose. It's very round. This is giving the bullnose shape, and you see that the plaster, the texture has broken off. This does not look like structural movement. This looks like impact damage. I don't have any idea of what caused the impact, but that is not structural. I would report that. I would report that as damage. I would disclose that I don't feel it's due to structural movement or any sort of structural failure, but I'd also say I don't know why it's there. Now over here we have a crack in the drywall, the crack right here. So now we're forced to say, is there structural movement or is there foundation movement? Well, at this point, it really helps to understand how the home is constructed. So let's walk back over here. This is most likely a load-bearing wall, just because of what we see. And then they have this arch that's created, but we have another likely load-bearing wall that comes at an angle to this one. That means there is additional load placed here. You probably have a horizontal beam, and then this is just framed in with scab pieces to be able to give you the arch. So this is a change in load. So that crack, I'm not surprised to see it there. And that crack doesn't appear to be wide enough to make me concerned about either the foundation or the framing. But that's definitely something that you should address, you should report, document it, and at this point, all that I would tell the client is that they need to take a picture of it or keep my report, which would have a picture of it. When you document something and you suggest to the client that they monitor it, you need to give a scale. Otherwise, they just look at it and say, well, I think maybe. I use a 6-inch ruler. It's got millimeters and inches, and I'm not particularly worried about what the reading is now. It's simply a reference for later. So I would take that picture and I would put it in my report so that it could be referred to later, and then the client would be able to say, based on that photograph, it hasn't moved. And if the homeowner goes to sell and they say, well, look, there's a crack, our inspector thinks you have a foundation problem, they're able to say, when our inspector looked at it 5 years ago, that's exactly what it looked like. There's no movement and no concern. An excellent place to look for evidence of foundation movement is crown molding. Drywall is forgivable. They put the bullnose on there, they put the tape, they put the mud, they put the texture, and they can repair that. Crown molding is done with very accurate cuts and measurements, and there should not be any gaps when they cut it, and there should not be any gaps later. So when I see the crown molding with no evidence of movement, and I see this and no other movement, it goes back to, I see it, monitor it. I see what might be a horizontal, I think it's less a crack than it is a poorly done joint in the drywall. This is what's called platform framing. They build a wall 8 to 8 foot and they build another wall above it. So if you look at that, that's right at the top of an 8-foot wall, and that's where they're going to have joints in the drywall. Remember, when you're in these houses, it's not yours. Be respectful respectful of the property. Don't disturb stuff, don't wander, don't snoop. Go back to our crown molding. We don't see any separation there. If you have a light that doesn't come on, is it a failure of the electrical system or is it just a blown bulb? We really don't know. So my job is not to go and do forensic testing to determine whether it's a bad bulb or something else, but I do note that you have a light that's not functional. We see some more of that damage here. Again, it's not structural movement, it's some sort of impact damage. I will confess that I caused that sort of damage when I bring my camera case inside and strike a wall in the hallway. I'm familiar with it. My wife is familiar with it. She's learned how to texture just to correct my damages. The standards for stairs changes a lot. It hasn't changed recently though. One of the best ways to determine if a stairway has been built correctly is to walk up the stair. I promise you, if you're uncomfortable walking up or walking down, the stairway is not built well. The handrail has to be graspable. The handrail has to be continuous so that you never have to take your hand off this rail to reach the top. And if it turns, the handrail can stop at the landing. Otherwise, it needs to be continuous. You need to be able to turn the light on from the top or the bottom so that you're never going up or down in the dark. As a part of the interior inspection, we're required to test the overhead door operator. Before you even pretend to test the operator, the first thing you should do is make sure that it is unlocked. If you try to open a locked door with the motor, something's going to be damaged. In this particular case, they drove a screw right through here that prevents it from locking. All right, so now let's raise the door. The manufacturer says to test this door for auto reverse, and that's for the safety of children. To test the door, use a 2x4. Well, I'm using a 2x2 because it's easier to carry, but it still has the same effect. And you'll notice that is a genuine 2x2. That's not just a throwdown 2x2. So we're going to come over here and shut the door and see that it should reverse within 2 seconds of hitting that board. And it did. I know that there's some who do not test the auto reverse feature of the door. This is a storm rated door and you see all these reinforcement struts. If this were a lightweight door, I might not test it. If there were any evidence of damage here, I would not test it. And that's likely damage caused because they didn't disable the lock. But in this case, I felt comfortable testing that. I know that there are also some who simply stand under the door and hold it and see if it reverses. I've done that myself. But in this case, what I can do is say, this is the way the manufacturer says test it, so that's the way I test it. Let's talk about an attached garage. There's a requirement for fire separation between the garage and habitable space, and a requirement for separation between the garage and the attic space. The drywall that you see here has a 20-minute fire rating. That's adequate. If there is living space above, that should be 5/8 inch type X drywall for increased fire separation. But you're not going to know that unless you just cut holes in it, and we're not doing that. So what's important to us now is that there are no penetrations, assuming that there are no penetrations behind these areas that are not visible to us. But because we have that fire resistance requirement, this door has to meet that same standard. And it's not just the door, but it's the door assembly. Now the standard is if you have a 1 3/8 inch solid door, or if you have a metal shell and some other things, that it's fire rated. This one doesn't have a label here. It is 1 3/8 inch, so even without more information, I can tell you that it meets the requirement. Ideally though, we will find something that says it's fire rated. It's going to say 20-minute fire rating Sometimes it has the Roman numeral X or two X's. So two X's in the Roman numeral is 20, so it's a 20-minute fire-rated door. But even with that label up there, it meets the standard. However, what it does not meet is the requirement that it be self-closing. The best door in the world is not fire-rated if it's open. So now self-closing hinges, it should be self-closing and self-latching, because it could be closed, but the draft created by fire can easily pull that door open. Should be self-closing, and that is something I'd write up, and it is a safety, it's a fire safety issue. Well, we've moved to the inside now. The first thing I would suggest is that you're courteous to the homeowner and to your client. Wear shoe covers. It's easy. These came from InterNACHI. They have a very good shoe cover. It's reusable. This cost about $14. You can also get disposable shoe covers. And my personal practice is I use the durable shoe cover, and I let my clients have the disposable shoe cover. And they respect the fact that you take care of their floors, so it's a good idea. This area, all right, now a lot of the appliances, if not all of the appliances in this area, are not covered by the InterNACHI Standards of Practice. It says don't inspect appliances. Know your own standards of practice, because that actually protects you. You can say, I did exactly what the standard says, but if you fail to inspect something the standard requires, that's on you. So be diligent. My standards of practice would require that I inspect all of these appliances. We're not going to actually go through the process, but at least let me tell you what would be. There's a disposer here. The way to operate the disposer is to turn it on. I know it's kind of hard to believe it's that hard, but first thing you need to do is make sure there's nothing inside the disposal grinding area. There's nothing more disconcerting than starting a disposer and finding out that there's a spoon in there. And in this particular case, the disposer is over here. They have a screen over it, so I'm not concerned, and we would find the switch and we'd operate it. You have a dishwasher. Again, the test is simple as operating it in normal modes. However, what you have to worry about is water from the sink running backwards into the dishwasher. You need to either have a hose loop where the hose comes up this high, or an air gap. And this air gap device is what protects water from coming backwards into the dishwasher. There's a hole here that should always face the sink. I find a lot of homeowners will turn it that way because they think those holes are a little ugly. And then if it ever backs up and does its job, water goes all over the countertop, it makes them angry, they get rid of it, and then they have problems with their dishwasher. So the air gap should always face this way. The oven. The most important part about the oven is to make sure that for safety, it has an anti-tip bracket, and that would be to keep it from tilting over. Make sure you look inside the oven before you try to do this, otherwise you could have grease. Okay, there we go. So right there, there is a bracket. If there's no bracket, it is safety and a deficiency. Here we have the microwave. Now the microwave has the range hood exhaust system built into it. And we saw outdoors the exhaust that did not have a cover. Let me make it visible to you. There we go. So that cover is missing from the outside, and it had a backdraft damper on the cover, so that must be replaced. Otherwise, you just have air that's drawing back into the house. The standard test for a microwave is it should boil 1 cup of water in about 2 minutes. I carry a plastic measuring cup, fill it with water, and test it. After you test the range, you would test the cooking elements on gas. It would just to make sure that they light. And you would test the oven using a thermometer, just a standard cooking thermometer. And at the end of a period of time, I use 30 minutes, it should be plus or minus within 25 degrees of 350. So set at 350. If my thermometer says between 325 and 375, I'm okay. Refrigerators don't typically stay with a home. There is no standard of practice that I deal with or InterNACHI deals with that says there's a way to inspect that. So frankly, if I'm inspecting it at all, I am basically saying, well, in my reasonable opinion, that's cold. And in my reasonable opinion, that's freezing cold. Seems to be working. But I did note that the handle came off. That would be reportable if that were staying and I were inspecting it. So that's the extent of what we would look at here in the kitchen for InterNACHI. I would have tested all of these appliances for the applicable standard of practice. The cabinets are not a part of the standards of practice. However, it's never a bad idea to look at it and see if perhaps it was fastened incorrectly or separating from the wall. We don't see any separation there. We don't see any separation here. Well, the reason it's not a part of the standard is we don't know what those fasteners went into. Did they go into studs? Did they go into blocking? Did they go into drywall? We don't know. So all that we can do is say, I see some cabinets that are failing, not we see cabinets that are performing. These look fine. Well, we've wrapped up another inspection. Let's just summarize what we found. Now, what the client most often wants to know is what are the big items? And the biggest items to discuss are obviously the foundation, roof, and most often the HVAC system. Foundation's in good shape. The roof is 12-year-old roof, but there's no problems with it. At 12 years old, they shouldn't have any problem getting insurance, but our inspection is not designed to get them insurance. They still need to check with their insurer. There's some issues with workmanship on windows and walls, the type of caulk and the way they've put the cement boards together. There's gaps that haven't been caulked. There's a few places that are chipped, but overall it's functional. The HVAC system was replaced in 2020. It was too cold to test the cooling system, but the heating system was fine. There were some issues with the condenser outdoors that it wasn't done quite as it should have been, mostly small code issues, but I point that out to the client. The heating system was functional. The water heater had been covered with a wrap, but based on the relief valve, I would say it's original to the house. That means it's about 12, 13 years old. That's about the end of its life, but we're not evaluating remaining life, so it's just something to kind of be aware of. It did produce hot water. It did recover, so I don't see anything there that says you have an issue with the water heater. The next things would be electrical. There's one issue that's extremely important. When they installed a generator, which was not inspected, when they installed the generator, they cut the original ground and they failed to reinstall a ground rod. So as far as I'm concerned, that's an ungrounded electrical system, and that's a big problem. Easy to fix, relatively inexpensive, but that is a must fix. There are a lot of other issues with electrical that are mostly related to change of code. Per the standards of practice that I have to follow, you don't have as many GFCIs. The GFCIs aren't where they're required to be. You're missing AFCIs. All of that is a change of code. So I'm reporting it to my client, but I'm trying not to get them to panic. I'm letting them know that we're telling you this so that you know that there's some safer ways to do that, not that anybody has to step out and replace those or add those. With regard to the smoke alarms and the carbon monoxide alarms, they have enough of them, but they're in the wrong place. So the simple fix for those is to reorganize them so they put the combination alarms where they're supposed to be and the smoke alarms where they're supposed to be. We did not test the appliances. We did look at the installation of the appliances and found no problems. So in the standards of practice I would follow during a complete inspection, every one of those things would be tested. Everything else is pretty good. We had some limitations in the attic. They had installed a radiant barrier on the floor, covering the joists, covering the insulation. And frankly, that made me really cautious about traveling anywhere in the attic off of that very small service platform. Everything else, I used a spotlight and I looked as far back into the corners of the attic as I could. Didn't see any evidence of a structural concern, didn't see any evidence of water intrusion, water penetration, or other damage. I think the house is in pretty good shape. Well, the next step for me is to write a report. There are a lot of different report writing softwares out there. Just follow the standards of practice. I have a specific form that I have to use. Do whatever your standard of practice requires, because that's your protection against any claims made against you. I followed this standard. It said I should do this, I did that. It says I don't have to do this, I didn't do that. That's your protection. I'll be writing this report. I include photographs. I find that the photographs help my client understand the report. Sometimes it's no more to say, this is the water meter, this is the shutoff, this is the gas meter, but I'll also use it to show this is where the ground has been cut. This is what needs to be fixed. This is the issue with the air conditioning condenser. This is what wasn't done right, and you could do this. You're not going to likely negotiate for it, but you could do it. I'll take pictures of the damaged drywall, of the crack in the drywall. All of that shows that I saw it and I considered it in rendering my opinion about the foundation. I'll include the pictures of the ventilation so that they understand this is what I'm talking about when I say ventilation. So I try to make the report understandable, not to another inspector, but to the client. The client is the one that I am educating. So you yourself may have seen me refer to some things that you don't know what I was talking about. That might mean that I didn't do a good job of explaining it, but it also might mean there's an area that you need to go do some training. InterNACHI has some great training classes. I encourage you to take advantage of those. I promise you, even if you understand the system, taking the class will help you learn more. My name again is Clay Collins. My company is Grace Home Inspection Services. Thank you for joining me, and I hope to see you again in another video.